Welcome everybody to MathLab. So in math, there are four main topics listed here. And in this channel, I will be going through all of them and with some tips on how to tackle each question types. Again, I will try to be as casual as possible, but for those that wants to be intense and wants to grind really hard for competitions, you can go very intense. I will link some very hard questions on all topics. Without further ado, let's begin. Chapter 1 is combinatorics, and the first topic is inclusion and exclusion.
So, let's have a quick recap on the basics of combinatorics. How many ways are there to rearrange the order of A, B, C, and D? There's actually 4 factorial ways, or 4 times 3 times 2 times 1, or 24 ways to rearrange A, B, C, D. You can think of it as using A, B, C, D to fill out this 4-letter word where each letter can only be used once. So the first letter can only be A, B, C, or D, right? That's 4. And once you choose out a letter, the next space can only have 3 letters remaining to choose from, for A, C, and D in this case. So 3. So once you multiply them out, you will get 4 factorial. And that's the case for the general assumption of n factorial. If you're unfamiliar with it, you can look at some videos about it, but these are the basics. The second rewind of the basics is that it's slightly more difficult. How many different ways can you choose pairs of letters from A, B, C, D, E, and F? So you can have A and B as a pair, you can have B and D as a pair, E and F as a pair, and etc. There's a lot. So there's actually 2 ways, where 6 is the number of letters you choose from, and 2 is the number of letters you want for each group. And you calculate this by using this formula. Which is 15. You can think of it as this. You can only use A, B, C, D, and F to fill out this 2-letter space. So for the first letter, you can have 6 choices, A, B, C, D, E, and F. So let's say you choose D. And on the next space, you can only have 5 ways to choose it because you already used one. But here's a catch. D and E shouldn't be any different from E and D, because these two are essentially the same case, which is why you need to divide by 2. So hence, you should have 6 times 5 over 2, which is also 15. Now this is just a brief summary, and I really suggest you to look at some videos if you're unfamiliar with it, because we're going to be using these a lot. So, we get into inclusion and exclusion now, which is basically what we did, but with a catch. So here's an example question. How many numbers from 1 to 100 inclusive are divisible by 2 or 7? So we count. From 2, we know that 2, 4, 6, 8, etc. all the way to 100 are all divisible by 2, which is 50 numbers. Pretty straightforward. For 7, there's 7, 14, 21, all the way to 98, which is 14 numbers. So when you add them up, that's 64. But hang on, there's a catch. Because look at 14. It's in the list of 7, but it's also in the list of 2 somewhere in the future here. But we overcounted those. We counted them in both lists. So what we need to do is that we need to subtract those numbers, because 64 is too large. We overcounted a lot of cases. So what cases are there to subtract? We subtract out the number of cases that are divisible by both 2 and 7. So 14. So how many numbers between 1 and 100 are divisible by 14? There's 14, 28, blah, 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 98. That's 7 numbers. So, in conclusion, the answer will be 64 minus 7 equals to 57. And that will be our final answer. We counted 2 and 7, and we minused the overcounted cases.
Now we have an example question for you to try yourself. Feel free to pause the video. I will review the hint in 5 seconds.